Here we go. Binomial expansion. Expand the following. So we have the binomial x cubed minus 2 divided by x to the power of 4. We want to use the binomial theorem. First thing we got to do is identify our x value. That's the first term in the binomial. We're going to find our y value. That's the second term in the binomial. And what's the n value? 4. Wicket. That's the exponent. Now, if n is 4, how many terms should there be in the expansion? How many? 5. There's one more. If the exponent were 10, there'd be 11 terms in the expansion. And this also tells me what row of Pascal's triangle to use if I go that route, or what combinations I should use. So my first term actually starts with the combination of 4. And what do I start? The first term actually goes 4c what? 0. And then I'm going to go a set of brackets followed by another set of brackets. What goes in the first bracket? X cubed. What goes in the second set of brackets? So it's your x value and your y value. Always. They follow this pattern. What are the exponents? What's the first exponent going to be? 4. And the second exponent? 0. Remember that this combination always matches the second exponent. Also remember that your exponents have to add up to n, in this case 4. And then I just make a pattern knowing that these exponents, the first exponent is going to start at 4 and count down to 0. What's the second exponent going to do? Start at 0 and count up to 4. Plus, what's the combination I'd use here? C1, good Brody. And then it would be x cubed to the third, negative 2 over x to the power of what? 1. Remember, that number is going to match that exponent. X cubed and negative 2 over x. I'll have 4c2. Remember that I'm also working my way across to what? 4c4. So this is what my pattern is going to look like. The first bracket always gets your x value, in this case x cubed, whatever that first term in the binomial is. The second bracket always gets your y value, or the second term in the binomial. In this particular example, it's always negative 2 over x. Remember your exponents. The first one goes 4, 3, 2, 1, 0, descending power. And the second one goes ascending power, 0, 1, 2, 3, 4. Remember, this number matches the second exponent always. Now we can figure out these combinations. What is 4c0? It's a 1. When you raise a power to a power, what do you do to the exponents? Add them or multiply them? Multiply. X to the 12th is what I would get. Anything to the power of 0, it's a 1. 4c1. Okay, that's a 4. X cubed cubed, that's x to the 9th. This gives me negative 2 to the first, negative 2 over x to the first, x. Anyone know what 4c2 is? It's a 6. This is an x to the 6th. What's negative 2 squared? Positive 4. Good, Brody. What's x times x? 4c3 is 4. X cubed to the first is x cubed. Negative 2 cubed would be negative 8 over x cubed. Don't forget to raise the numerator to the power of 3 and the denominator to the power of 3. And then finally, 4c4 is a 1. X cubed to the power of 0. That would be x to the power of 0, which is a 1. And negative 2 to the fourth is a positive 16. X to the fourth would be x to the fourth. Multiply. 1 times x to the 12th times 1. X to the 12th. 4 times x to the 9th times negative 2. Negative 8x to the 9th over 1 times x. 6 times x to the 6th times 4 is 24 x to the 6th. 1 times x squared is x squared. 4 times x cubed times negative 8 is negative 32 x cubed over 1 times x cubed, x cubed. And finally, 1 times 16 is 16. 1 times x to the fourth, x to the fourth. How can I clean this up? What's the rule when you divide powers with the same base? Right, I would write my base down x and I would subtract the exponents 9 minus 1 to get 8. This is going to be 24. X to the what? Fourth, good. What about this next one? Just a negative 32. You could write x to the 0, but remember x to the 0 is what? It's a 1. Negative 32 times 1 would be negative 32. And finally, 16 over x to the fourth. Notice they go down by 4 each time. 12, 8, 4, 0, negative 4. Okay, or there's a 4 on the bottom. And as predicted, how many terms are in that expansion? 5. 1, 2, 3, 4, 5. You could use combinations or Pascal's triangle. Row 4 of Pascal's triangle is 1, 4, 6, 4, 1. We'll have a question like that on your exam. Question like this may show up somewhere in the multiple choice section. It says find the term in the expansion of 2x plus y to the power of 8 that contains x to the fifth y cubed. For starters, what's the first term in the binomial? What's the second term in the binomial? And what is the exponent? Now, I don't have to figure out the full expansion. How many terms would there be in this expansion? There'd be 9 of them, because the exponent is 8. I'd be using row 8 of Pascal's triangle, or I would be using the combinations of 8. Now, I want to know what term contains this, the x to the fifth and y cubed. This is kind of the key, that second exponent. I know it's going to start with 8c what? 8c what? 3, that's right. If I only want the term that has the y cubed, I know that if this is 8c3, that's the one that's going to have a y cubed. I'd fill a 2x in here, a positive y in here. If that exponent's a 3, what's this one have to be? Remember, they have to add to n. They have to add to 8. 5. And we figure this out. Anyone know what 8c3 is? Confirm this. 56. What's 2 to the power of 5? 2 times 2 times 2 times 2 times 2. 32. What's x times x times x times x times x? X to the 5th. And then I'd have y times y times y, y cubed. 56 times 32 gives me 1,792 times x to the 5th times y cubed. This would actually be the 4th term in that expansion. Why the 4th term? Because you start at 8c what? 0. But I didn't have to do the whole thing. I could figure out which term had the x to the 5th y cubed by using that knowledge there. It's the combination of 3 that's going to give you the second exponent of 3. All right, so that is binomial expansion. Let's move on to combining functions. There will be a question like this on your exam. So here's the situation. They give us f of x, g at x, and h at x. In each part, A, B, C, and D, they get me to combine 2 of these 3. How do I combine them? I either add them, I subtract them, I multiply them, or I divide them. They want me to come up with the new equation, k at x, and they also want me to give the domain of k at x. Remember, the domain of the combined function is the domain that's common to the original 2 functions that you're working with. Keep in mind that when you divide, you have to think of your non-permissible values, because what number can you not divide by? 0. Okay, so I'll show you what I mean by that in part D. For starters, let's talk about f of x. What type of curve is f of x? It's a parabola. It's a degree 2 polynomial. It is going to look like this. What is the domain of f of x? Left forever, right forever. Awesome. G at x. It's also polynomial, but it's not a second degree. It's a first degree. What do they look like? It's a linear function. It's a straight line. The domain would also be x belongs to the real numbers. H at x is a logarithmic function. We studied them in Chapter 8 of Pre-Cal 12a. It's going to look something like this. It's the inverse of an exponential function. Do you remember how to find the domain of a logarithmic function? You take the argument, okay, the thing in the brackets, in this case 3x minus 2. And it has to be greater than 0. Not greater than or equal to, just greater than. And then we solve this inequality. How would you solve that? Add 2 to both sides or move the negative 2 over. How would I get it to say x? Divide each side by 3. I have x is greater than 2/3. If I divided by a negative, what would I have to do to the inequality? I'd flip it. Yeah, if that said negative 3x is greater than 2, x would be less than negative 2/3. Not the case. My domain is x such that x is greater than 2/3. X belongs to the real numbers. Everyone okay with that? All right. For part A, I am combining f and h. So the new equation, k at x, is going to equal f at x squared minus 2x minus 8. That's the parabola. That is the second degree polynomial. And I'm combining it with the logarithmic function, log 3x minus 2. How am I combining them? Addition. Now, is there anything I can do with that? Like, are there any like terms? That's as simple as it gets. That would be the equation of k at x. The domain of k at x would be the domain that's common to the quadratic function and the logarithmic function. So this one has a domain of x belongs to the real numbers. This one has the domain of x is greater than 2/3. What numbers would be common to both? Greater than 2/3, that's right. X such that x is greater than 2/3. I couldn't use something less than 2/3. Like I couldn't use 0. Yes, 0 would be on this or in this domain, but it's not in this one. X belongs to the real numbers. Close the brackets. That's set notation. Who knows what that would look like in interval notation? I'd go from 2/3 to infinity. What type of brackets? Round, because it cannot equal 2/3 or it cannot equal infinity. Infinity is not a number. It's the process of getting bigger. On to part B. This time I'm combining G and F. Remember, G at x is the linear function, x minus 4. F of x is the second degree polynomial, or the parabola. How am I combining them this time? With a minus sign, I'm subtracting. What should I do in order to simplify this? I got to distribute the negative, so that's why I put the brackets. When I distribute the negative, this would become negative x squared. This would become positive 2x. And this would become positive 8. Group your like terms. Negative x squared plus x and 2x, or 1x and 2x. How many x's would that give me? And then I have a negative 4 and a positive 8. Plus 4. There's my new equation. When I'm trying to figure out the domain of this, remember it's whatever's common to the original two. F and G. Both are x belongs to the real numbers. Therefore, this would have the domain of x such that x belongs to the real numbers. In interval notation, what would I write? From negative infinity to positive. We got f times g. In the next example, in part C. So let's write them down. F is x squared minus 2x minus 8. And g is x minus 4. How am I combining them? Multiplication. When I simplify this, let's multiply this out. I've got 3 terms by 2 terms. How many terms should I end up with? 6. What's x squared times x? What's x squared times negative 4? What about negative 2x times x? Or negative 2x times negative 4. What would that give me? Negative 2x times negative 4. Positive 8x. Good. Negative 8 times x, negative 8x, and negative 8 times negative 4, positive 32. Group your like terms. X cubed minus 6x squared. 8x minus 8x is going to go away. Plus 32. And the domain of this will be the same as the previous one. Okay, what's common to f and g? This is all the x values. This is all the x values. So my combined functions domain would be any x value at all. X such that x belongs to the real numbers. Okay? Part D, this is where I have to consider the non-permissible values. This time I am combining h, the logarithmic function, and g, the linear function. K and x equals the log of 3x minus 2. Who knows what the base of that logarithm is? It's not written. What's it understood to be? 10. Good. It's a common logarithm. Excuse me. G at x is x minus 4. Consider the non-permissible values. How do I figure out the non-permissible values? What can I not divide by? Anyone? Mathematically illegal to divide by 0. So I am going to take the x minus 4 and say that it cannot equal 0. Or x cannot equal 4. I have to include that in my domain. This does not simplify. That is the equation of k at x. The domain, though, however, I want to say that it's going to be the domain that's common to the red and green. Red is x belongs to the real numbers. Green is x is greater than 2/3. So what's the combined function or the combined domain? X is greater than 2/3. Great, Leah. X such that x is greater than 2/3. But I have to add something. That's right. X cannot equal 4. X belongs to the real numbers. When do you have to add the non-permissible values? When you combine them through division. Wicked. Here's what that would look like in interval notation. I'd go from negative infinity, 2/3 to 4. And then I'd go from 4 to infinity. All right. All right, that's the show. You can continue working on your exam review. Don't forget the exam is Tuesday morning.